Modus ponens and modus tollens gave us our first argument forms in sentential logic. In this video, we're going to look at some additional forms of sentential arguments. But to start, we got to back up and talk about truth functional connectives. Truth functional connectives are words or symbols, or sets of words or symbols, which can either be added to simple sentences or used to join simple sentences together to form new complex sentences. An example of a simple sentence would be something like, I have a dog. And then a compound sentence would be something like, I have a dog and I gave the dog dinner. So when I'm talking about simple sentences, I'm talking about those basic building blocks of larger compound sentences. Words like and, or, and not are truth functional connectives, as well as cases of if, then, like what we looked at in previous videos, and if and only if. These are not the only cases of truth functional connectives, but these are the only ones we'll be looking at. When components of a compound sentence are joined by truth functional connectives, the truth or falsity of the compound sentence depends entirely on the truth or falsity of its components. That's where the name truth functional portion of the truth functional connective name comes from, because the truth values of the sentence are a function of the simple sentences and the connectives. So, for example, as we've seen, when if then is interpreted as a material conditional, which is how we're interpreting it in this chapter, it is a truth functional connective because the conditional is false only if the antecedent is true and the consequent false. Otherwise, the conditional is true. It's truth functional because just by knowing the truth values of the simple parts and the relationship between the connectives and the simple parts, we know the truth value for the sentence. Another example is not. If the sentence P is true, whatever P might stand for, then the sentence not P is false. Similarly, if P is false, then not P is true. Pretty straightforward. So in the last video, well actually I think it was 2 videos ago, we got this table. This table shows the truth conditions for conditional sentences. 4 sentences that have the truth functional connective if, then. And as we saw then, the only time a conditional sentence like this, when understood as a material conditional, is going to be false is when the antecedent is true and the consequent false. In all other circumstances, the conditional is true. The table for not is really basic. If a claim is true, then its negation is false. And if a claim is false, then its negation is true. Implicitly, what's going on here, we're relying on 2 different types of principles. The first is the principle of the excluded middle. The principle of the excluded middle is the principle that every well-formed declarative sentence is either true or false in the context in which it is uttered. So what do we mean by well-formed declarative sentence? So we mean the sentence isn't something like a sentence fragment. Those things don't necessarily have truth values. They're not necessarily true or false because they fail to express something. They've also got to be declarative sentences. So for example, if I give a command, or ask a question, or make an exclamation, those things may not be true or false. In fact, they probably aren't. But when the sentence is declarative, it's a claim being made. If it's a well-formed claim being made, either the sentence is true in the context in which it is uttered, in the context in which it is spoken, or written, or what have you, or it's not. So, for example, the sentence, it is raining. While this claim is true in some contexts and false in others, it is always true or false in any given context. So the principle of the excluded middle doesn't claim that the truth value can't change depending on a change in context. It's just claiming that when a well-formed declarative sentence is spoken or written or otherwise uttered, it's going to be true or false in that context. So it can be true in some contexts and false in others, but it will always be true, or false. It's true if it's raining at the place and time of utterance in this example, and it's false if it's not. So this is a principle of logic that we're assuming that undergirds, that supports what's going on with the arguments in sentential logic. The other principle we're appealing to is what your book calls the principle of contradiction. It's also, I think, more frequently called the principle of non-contradiction, but regardless of the name, the principle states that no sentence is both true and false in a particular context. Once again, you got to pay attention to this in a particular context clause, because it could be true that in context A, it is raining is true, and in context B, it's false. Let's say context A is in the desert where it's currently not raining, and context B is somewhere in London where it currently is raining. Just because it's true in one context and false in another context doesn't mean that there's any violation of the principle of non-contradiction. All the principle of non-contradiction says is that it can't be true and false in the same context. When you utter it is raining at a given time and place, either it is true of that time and place, or it isn't. With these preliminaries taken care of, let's take a look at some of these additional sentential arguments. The first one is the hypothetical syllogism. And here's an example of the hypothetical syllogism. It's a two-premise argument in which both premises are conditionals. Okay, so in this example, the first premise is if inflation can be controlled, so inflation can be controlled is the antecedent, then business will expand, where business will expand is the consequent. The second premise starts with if businesses expand, so notice that the consequent of the first conditional has become the antecedent of the second. Then unemployment will decrease. From this we conclude, therefore, if inflation can be controlled, then employment will decrease, where we've taken the antecedent from the first premise and the consequent from the second. So, this is the form of the argument. If P, then Q. If Q, then R. If P, then R. This is a valid argument form. So no matter what P, Q, and R are, if both these premises are true, then this conclusion will also be true. You can see why if you think about it this way. If this first thing happens, then necessarily the second thing will happen. But if this second thing necessarily will happen, then this third one will. Which means that once the ball gets rolling with this first event, it will lead to the second, and the second will lead to the third, such that the existence of this first condition is sufficient for the third one. You get this sort of cascading chain of events. In actuality, you could make this as long as you wanted. You could have, for example, a three-premise argument that said if P then Q, if Q then R, if R then S, and then conclude if P then S. Whenever you've got a chain of conditionals like this, the antecedent of the first one will lead all the way to the consequent of the last, so long as each step of the chain takes the consequent of the first conditional and moves it into the antecedent of the next. The next argument form we're going to look at is one of the more complicated ones, and probably one of the less intuitive ones right away to see why it's valid. It's the constructive dilemma. And here's an example. The constructive dilemma has three premises, the first two of which are conditionals. So let's take a look at this particular example. Our first premise, if I spend the weekend partying, then I will fail some midterms. So we've got our standard if-then relationship, where if you do the one thing, spend the weekend partying, then something else will follow as the consequence. You'll fail some exams. Second premise, if I spend the weekend studying, so a different activity you could do this weekend, partying versus studying, then I will miss out on some good times. Third premise, I will party this weekend or I will study. Alright, so apparently in this argument you're not much for multitasking or splitting your time. It sounds like you're either going to do one or the other. And the conclusion drawn from this, therefore, I will fail some midterms, or I will miss out on some good times. The structure of the argument is this. The first premise, a conditional, if P then Q. Second premise, also a conditional, with a completely new antecedent and consequent, ones that we haven't seen yet. So we have if R, then S. The third premise, P or R, then we conclude from this Q or S. This is a valid argument form, meaning that whenever all three of these premises are true, then this conclusion will be true. But it might not be obvious right away why this is so. To see why, let's first zone in on this third premise here, P or R. So, in the constructive dilemma, because the third premise says P or R, we know either P is going to be the case or R is the case. But the first two premises we have tell us about what follows if P is the case or if R is the case. The first premise tells us that if P is the case, then Q, and the second premise tells us if R is the case, then S. But we know one of these two things has to be the case, therefore we also know one of these two things has to be the case. And that's what the conclusion claims. Q or S. But this point about Q or S leads us to something else that we need to talk about, namely disjunction. Compound sentences whose simple parts are connected by or are called disjunctions. In English, the word or has two closely related meanings. The first is or in the exclusive sense, meaning one or the other, but not both. So your book gives the example that if you're at a restaurant and you're told you can have soup or salad, that means you can have the soup or the salad, but not both the soup and the salad. That is or being used in the exclusive sense. The second sense of or is the inclusive sense, meaning just one, just the other, or both the one and the other. So if a bridge is open for pedestrians or bikers, that means either pedestrians can use it, or bikers, or both. In sentential logic, it is standard to understand or in the inclusive sense. Once we've established that we're using disjunctions in the inclusive sense, we can see that the truth conditions for disjunctions are as follows. When both P and Q are true, the disjunction is true. When P is true but Q is false, the disjunction is still true, because the one part is. When P is false and Q is true, same story, still true. It's only when both P and Q are false that we get the disjunction as false. Using this, we can look at another important argument form in sentential logic. This one is called disjunctive syllogism. The disjunctive syllogism is a two-premise argument in which the first premise is a disjunction, P or Q. Then in the second condition, you negate the first disjunct, the first simple sentence in this disjunction. So we've got not P. And from that you can conclude that Q. This is a valid argument form. Whenever both the premises are true, so is the conclusion. But why is this so? Stop and think about it for a minute. What we're claiming at the start is either P is the case or Q is the case. But then we get another piece of information. This first thing, P, isn't the case. Well, since one of them has to be the case, and it's not the first one, it's got to be the second one, namely Q. Alright, that's all for this video. And the next one, we're going to introduce some new symbols, which will help us simplify our expression in sentential logic.